Hello and welcome to Database Management Systems. I'm Javita Christie, and in this video, I'm going to explain to you query processing. And this is just an introduction to how query processing happens in any database system software. So let's begin. What you see on your screen right now is a diagram of query processing. So this is how query processing works. And you can see there are several steps of the process. And this whole process is what I'm going to explain in this video. So it is divided into three parts. The first one is called parsing and translation. So that's your first phase. The second phase is optimization. And the third phase is evaluation. So in parsing and translation, the query is parsed and translated. In optimization, the query is optimized to make it cost less to the system. And finally, in evaluation, the query is actually implemented. So we are going to see one by one all these phases. So first, let us begin with the let us begin with the parsing and translation phase. So in this, the first action that the system must take in query processing is to translate the query into its internal form. So internal form in most cases is where a query is translated into a relational algebra expression because these expressions are easier to evaluate. And if you have studied relational algebra and SQL as well, you will already know that relational algebra in itself is a procedural language because you need to specify in relational algebra which operation should happen first, which should happen second, which should happen third. So that's why relational algebra is procedural, but SQL is declarative. And we know that when we run a software, which is a DBMS software, like the ones that I've used in my videos, like SQL Plus, that software is where we write our SQL queries, which are declarative. And I cannot specify whether I want the system to do the select operation first or the project first or what I want them to do. So that's why first, the query is converted into its internal form. And once that is done, then the parser is going to check the syntax for the user's query. After converting it into the internal form that the system understands, the parser will then try to understand the syntax of the query and check if the syntax is correct or not. Because this is very important, since if the syntax of the query is incorrect, then you'll immediately get an error right there in your command line. And you know this already because you've studied SQL in my previous videos. So whenever there's a problem with the syntax, for example, if somebody is writing the where operation before the select operation, or the from operation after the where operation. So if these types of syntax errors are there, then the query is not going to be run and it will directly just give you an error. So that's why the first step is to perform parsing. So the system will also verify the relation names that are appearing in the queries, and it will make sure that those tables are available in the system. This is the first thing that is checked, that whether the table names that are mentioned in the query are actually present in the system or not. So that is your first test. And after that, the whole syntax of the query is checked if the column names are correct or not, if the conditions given are proper or not. So this is how parsing and translation takes place. And afterwards, the system constructs a parse tree representation of the query. So parse tree representation of the query is where each operation is written in the form of a tree. And you'll understand this better as we proceed with this query processing in my further videos. So you'll understand what a parse tree is. But a parse tree is nothing but where operations are kept in a hierarchical order, and then this parse tree is translated into a relational algebra expression. Because, like I said, relational algebra is a is not a declarative language, but procedural language, whereas SQL is declarative. So we have to convert it into this type of a procedural construct. The next thing that happens is if the query was expressed in terms of a view, then the translation phase also replaces all uses of the view by the relational algebra expression that defines the view. So I've done a video on how to create views in SQL. And if you're not familiar with views, I would highly recommend that you watch that video to understand the statement that you can see right here. So what is a view? A view is nothing but an imitation or an impression of the original table. But it's not a full impression. It is just the impression that you want to create of the table. So you can hide certain rows, you can hide certain columns and create a table that looks similar to the original one, but it's not a table at all. It's a query that runs every time you try to access that table. And that's why if you are trying to perform a query in SQL on a view, then the system will replace, first of all, that view with its original query. It will convert that also into a relational algebra expression. And it will also convert the query that you wrote into a relational algebra expression. Now let's consider the optimization phase. So in the optimization phase, there is a query given, but there are a variety of methods of computing the answer. There is not although the output is going to be one, but to get to that output from that query, there are many ways, there are many paths. So this is the place where these paths are evaluated, and that's what we are going to see here. So consider this. This is an example. So if you have a query like this in SQL, because that's what you are writing into your command line, the query says, select salary from instructor where salary is less than 75,000. So it's a very simple query. And if I want to convert it into a relational algebra expression, which is essentially what happens in the parsing and translation phase, then it looks like this. I have two choices. The first choice is writing the sigma operation, which eliminates certain rows from my table in this manner. I will write sigma salary less than 75,000. And then in bracket, I will mention pi salary and from the instructor relation. So notice that in the second option, I have interchanged pi and sigma. So I have taken pi first, which means salary column. And after that, I have applied the condition that is sigma on the instructor relation. But actually, if you try to read these queries, because they are relational algebra queries, you would read them from inside the bracket. So the first bracket, which is the innermost one, is the instructor bracket in the first query. So I will read from there. And after seeing the instructor bracket, I can see what operation is being applied. So in the first query, first the salary column is extracted. But in the second query, first the rows are extracted where the salary is less than 75,000. In the first query, after extracting the salary column, there's a condition that says salary less than 75,000. So this condition will apply and take out all the salaries which are less than 75,000. And in the second query, after getting all the salaries, all the rows containing salaries which are less than 75,000, the column salary is extracted. So these are the two different ways in which I can create a relational algebra query. And so does your system, your software that is implementing this SQL query. Now, after doing this, because this is such a small query and it only has select and project operations, it's generating only two options. But if you had a really large query, then it would generate several options. And from those options, one would be selected, which would be known as the evaluation plan. So in the optimization phase, out of all the options, first of all, obviously all the options are checked and evaluated in order to understand which is the best one. Sometimes it's better to do a pi operation before sigma, and sometimes it's better to do sigma before pi. So based on all the calculations, the system will select one option, and then that option is converted into an evaluation plan like this. So in this plan, I'm basically specifying what to do first and what to do next. This is a sort of a tree. So you can see the topmost thing is pi salary, and then I have sigma salary, and then I have instructor. So you have to start reading from the bottom, which means the first thing we are doing is extracting all the salaries, all the rows that contain salaries less than 75,000. And also one more thing that is mentioned is use index 1. So such types of instructions about which kind of index to use, whether to use a B-tree index or a hashed index, all these instructions are also added to the evaluation plan. So after doing that, the pi operation is applied. So this is how you can create an evaluation plan, and this is how a software that you use for a database is creating an evaluation plan. Now, different evaluation plans for a given query can have different costs, like I said before. So depending on which evaluation plan costs the least, we select an evaluation plan. And this cost is evaluated on the basis of how much time each operation will take. And not just that, but how many data items that operation needs to read from the hard drive in order to perform that query. So some operations might need less data items to perform the same task. And so they have to read less from the hard drive and fetch less data from the hard drive. So based on all these things, the cost is decided of each and every query. So this is how evaluation is done. And then this evaluation is actually done because, users, that is us, when we write a query in command line, we are not expected to write a query that is perfectly, optimized. We cannot even do that because we are writing in SQL, and in SQL, we cannot specify whether to do select first or to apply where condition first. Because SQL is just declarative. You just explain what you want. You don't explain how to get it. And so users do not write an optimized query, but then after the users write their query, the query needs to be optimized to pick the most efficient evaluation plan. And that's why it is the responsibility of the system to construct an evaluation plan that minimizes the cost of query evaluation. And this task is known as query optimization. Now, once a plan is picked, then we come to our final stage, which is evaluation stage. In this evaluation stage, once the query plan is already selected by the optimization phase, this stage is only about implementing that plan because all the instructions are given. Everything is told which operation should happen first, which should happen second. So everything is ready. Now the only thing that needs to be done is to actually implement the query and generate the result and give it to the user. So that is what is done at this point. So that's how the query evaluation process works. And I'd like to take a minute to just sum up all that we saw in this video and in this diagram. So in this diagram, first of all, you have a query. And then that query is parsed and translated. Parsing means simply creating an internal structure. So maybe creating a tree or something out of the query. And then translating the query into a relational algebra expression. And not just one expression, but you might want to translate it into several expressions, depending on how big your query is. And after that, once that whole thing is done, the relational algebra expression is ready, then the optimization phase comes. So in the optimization phase, the query is the relational algebra expressions are evaluated to find out which one is the most cost efficient expression. And then the evaluation plan is created, where not only a tree is generated, but also some instructions are added to it, like which index to use and where to get the data from. All these things are added in the evaluation plan. And once that is done, then the evaluation engine is going to implement the query and fetch the data, the actual data that is going to be displayed as an output. So that is the query evaluation process in a nutshell. And in the next video, I'm going to explain a little bit more about this process. So see you in the next video. Thank you for watching.